Well, hello, Nick here, M0NTV, and welcome back to the Shack and to another homebrew video. Sorry I haven't put anything up for a while, but I've been on holiday and all the rest of it. And I need to fess up, actually, right, right from the start. Much as I enjoy making videos about building radios, what I really enjoy is building radios. You know, not just making videos about them. So actually, I had a bit of a spurt on, and I just built this 17-meter rig. I just built it. I just went on and just built the thing, finished it, and I've put it on the air, and it's great. And next video, you will see it. We'll have the grand unveiling. You'll see it in all its glory, and I'll tell you about it. And you can see it working. That means that this video is not what I said it was going to be. What I advertised it when I made the last video about the small signal amplifiers was that I was going to do about the RF driver today. Now, actually, in truth be told, I did build the RF driver. Here it is, and I built this one. Now, this is a design that I've used many times. In fact, just about every single rig I've built has got one of these in, or a version of it. What's interesting, it puts out about a watt. What's interesting is that it's got a PNP transistor here with a couple of diodes here, and it's got a kind of temperature compensation thing in it to prevent thermal runaway. So even if, you know, things start to heat up, instead of the gain getting higher and higher, it just keeps that bias down to a constant level, which is really useful. So I built this and it works, and that's fine. But actually, when I came to build the PA, the power amplifier, I realised this was way too much power. And because I've got so much power coming out the small signal amplifier and the RF pre-driver, as I was calling it last time, actually the power MOSFET that I used in my PA, I didn't need anything like this power. In fact, I could just take this out completely. So I did. So I didn't use it, and actually I can drive it with just the power stages that I'd already got. So, you know, happy days, that's simple, and this can live to fight another day in another rig. So I didn't do that. But if you are interested in that particular design, the best thing I can do is to suggest you get yourself a copy of Building a Transceiver by Eamon Skelton and Elaine Richards. And truth be told, if I could recommend one book for somebody that was starting out in home brewing and just wanted some advice and some good simple circuits they could build, it would be this one. And I say that as a proud owner of Solid State Design for the Radio Amateur and Experimental Methods in RF Design, all brilliant books. But this one's very simple. It's got some simple practical ideas you can go away and build, and some very good advice about how you string it all together as well. So, and it's still in print, I think, and it doesn't cost very much money. It's published by the RSGB. I think I bought it from National Hamfest at the RSGB bookstore one year. So yeah, very good. Okay, so let's move on then and have a little quick look at the power amplifier that I did build and more or less completed the build of that rig. Now, the power MOSFET that I used in my power amplifier was actually an SD2931-10. And the reason I used that is because someone was kind enough to give it to me. Thank you, Tony. Plus a heatsink as well. And he'd used it as part of a homebrew linear amplifier. And now the 2931 is good for, well, it's rated at 150 watts, so you can see we're talking about some significant power here. Not that I'm going to try and get anything like that out of it, but we're certainly not in QRP land anymore with this particular amplifier. And I wanted to try and build something with a bit more power. I've never had much success with that particularly. Not that I have great hankering to use loads of power, but I just wanted to do it because I'd never, managed to do it thus far. Now, there is a data sheet, obviously, for that particular transistor, but I did read, in fact, I think it was in Skelton's book, actually, that there is another MOSFET, a different one, but is very, very similar in many of its characteristics, and that is the MRF151. And actually, I downloaded the datasheet for that, and I just liked the schematic a bit better that the datasheet provided. So that's what I went with. So it's a bit of a gamble. So I'm basically using a different MOSFET, but with the design for the MRF151. And this is it, or at least my little scribbling of it. And you will see in a moment the actual thing and some of it, how it came together. But essentially, it's a pretty standard design, really. You run it at 50 volts, so that sometimes is a bit of a challenge. You think, how on earth do I get 50 volts? So I use a boost converter, a fairly beefy boost converter, because it's got to take some current as well, but that's fine. Having said that, I did blow one up. I didn't blow it up. I blew the fuse in one, just because I was asking more current from it than it could actually supply. So of course the fuse is going to go. So I got a more beefy one, and that's fine. And if you look here, you'll see the actual supply line has got some ferrite bead. It's got a choke on it. You're basically just trying to keep out RF out of that power line as much as possible. All these decoupling capacitors here, just trying to do your absolute best to make sure there's no RF getting into the power supply. That's what this is about. On the output from the drain, which is being coupled again by a transformer, which is what you're taking the RF out, and that will go to the transmit low pass filter. You really want mica capacitors on those, so they're good for plenty of power and they're very reliable. They're more expensive, of course, and they're physically bigger, but when you're dealing with some power, you can't be taking any shortcuts with it, really, I think. So I did shell out and get some decent capacitors there. The bias is just coming through here. In actual fact, I used a voltage regulator and a potentiometer to control the amount of bias, so I could alter the amount of bias that was going through to the gate. And then the RF comes in again. It's inductively coupled then with that transformer on its way in. What I have found building power amps before is you need to do your best, really, to just keep it clean and tidy, and especially when you're dealing with more power and you've got RF in some quantity flying around everywhere, and that's especially important. Let me just show you the plan then that I drew up, where the components would all actually go on the board. And so here is the board layout. Hopefully you can just about make sense of my little scribbles here. And this, obviously it's not to scale now because it's blown up on your computer screen or your phone screen or whatever you're watching this video on. But the actual thing was to scale. I just drew round the actual board. And these are the etched pads that I connect the legs of all the components to. This is the space for the MOSFET. The MOSFET itself, you'll see it's one of these ones with a kind of north, south, east, west legs. And so the MOSFET itself is screwed and glued with thermal paste onto the heatsink below, and the board kind of drops down on top of it, or rather it it kind of drops down because these come through and connect obviously onto the actual board, but the actual body of the MOSFET is actually kind of screwed and glued below to the heatsink. So yes, you have to kind of make a hole here to accommodate that, and these are just to accommodate some other mounting holes that were on the heatsink that I had. And yeah, so that's it. So this is the space where the large transformer goes, and yeah, so it all goes on there. Fine, it's not all too cramped up or anything. It's a slightly larger board than the one that I would usually use, which was good because it meant I had a bit more space to manoeuvre there. So that's what it looks like there. So let me show you now some footage that I took as I actually built the PA, and so you can kind of see it coming together in some stages. So hope you enjoy.
Well, welcome back to the bench, and as you can see, you've got the schematic, got the scale diagram of where it's all going to be laid out, and here is the single-sided copper-clad board that we're going to use. And as you see, it's exactly the same size. I've drilled it out and made some spaces here as well for some other possible mounting of some enclosure on top of it if I decide to do that. And most importantly, a space here for the power MOSFET, which I can probably show. I'll try and do this with one hand. It's not the easiest thing in the world. To fit through, there we are, nicely, and we'll drop through there. And actually, the actual board is going to be mounted on little washers, so it will sit rightly. So yeah, this is yeah, it's a bit larger than the stuff I usually use, and that is going to be mounted on. Check out the heatsink. Look at this bad boy. Now that is a heatsink, right? And wow, so somebody kindly gave me this, thank you Tony, and he had it employed actually as an external linear amplifier that he'd homebrewed for 4 meters, I think, which is brilliant because as you can see, he's already got it all drilled out for the MOSFET there, and for all this, so that's all going to fit on there nicely. As I said, it will be raised up so that the MOSFET will sit flat, and I'll just put a bit of the thermal grease on there and screw it down. So that's great, and with something like that, I mean, that's going to sink a lot of heat basically. So we should have no worries with that. It doesn't make for the smallest of power amplifiers. But hey, when did I ever build anything small? So the next thing is to now have a look at the diagram. Essentially now I'm going to get busy with the Dremel and all these little conductive isolated pads. I'm going to engrave out on the FR4 then. So just before I Dremel and engrave all those little pads, just to say I've obviously marked it all out with a pen first, so I know what I've got to engrave. And I didn't say before, and I probably should have done, but of course I treated it as I always treat all of these copper-clad boards initially. So before I do anything, before I cut it to size or anything, I'll go over it with very fine wire wool and make sure by then going over it with a multimeter that I've got a very good conductive plane with very low resistance, no matter where you attach the meter to. Because sometimes when you buy these, they have a little kind of thin layer of lacquer on them. which makes them look lovely and shiny, but is not very good for attaching components to. So it's good to make sure that it's as good as you can get it first before you start. Right, okay, I'm going to get dremeling. Well, there we are, and so that's all engraved as I want it. Just to say, if you haven't seen any of the previous videos where I've talked about this technique, it's a really great thing to do. And these little Dremel things, well, mine's a cheapy equivalent. Yeah, great, and you can get some really good results. Because I use it freehand, like a pen, really, I find that actually I get better results if I just go vertically down. So what I tend to do, after I've marked them up, when I've got the Dremel, I'll do all the vertical strokes, leaving all the horizontal ones, just do all the verticals. Then I'll clean it up because it makes a lot of dust, and you want a pair of protective goggles on just to make sure these little bits of metal and dust don't get in your eyes. Then just turn it through 90 degrees. Then all these bits that were horizontal are now vertical, so go back and do all those. Then get yourself magnifying glass, go over it, and make sure that you haven't got any little stray bits of copper that are coming across. Get a cloth, give it a good old rub down, and polish it up, and check it all out again. Then when you're satisfied it looks good, go over it then with a multimeter and make sure that all these pads that are supposed to be electrically isolated from one another and the ground plane are. And if they're not, then fix it. And yeah, so, and that's it. And then I will just check it with a multimeter now, and then we can get populating the board. Well, just a status report. Most of it's on, actually. It's come together pretty well. It's taken me a little while to do it, a few hours, partly because I was faffing around with these RF chokes and just experimenting with different cores, really. Yeah, so, and it's not too critical, I think, really. The main thing is just keep doing as much as you can to keep any RF on that feed line going to the transistor and the transformer. Yeah, so it's all, so yeah, that's my 9-to-1 transformer on the input, the RF input, which is trifilar wound. And then this is a 1-to-9 this is, but obviously this is intended for some serious power. This is actually a kit I bought. If you ever built one of those cheapy Chinese linear amplifiers that always say you're going to get loads more power than you realistically will, it's very similar to that. So this one's rated up to about 150 watts, which is more than enough, really. And it's two little tubes. I should have videoed it before I put it together, really, but it's two little metal tubes which go through these cylindrical ferrites, and these end pieces, which are great. And essentially, what you do is you solder the tube. The tubes onto the end pieces when it's all together, so it all holds together, and then you solder the whole thing down, and because it's essentially one turn, which for a binocular is through and out, so that's one big conductive plane there. So these two bits are connected together, and these two are not, and so these two are separate. Yeah, so that works well. I had to use high voltage capacitors, obviously, for a lot of it, and some mica capacitors as well. The spec sheet calls for, and I've stuck pretty much to the spec sheet design. And obviously, I mean, these resistors, these are 2-watt resistors, so I didn't need as much as that. But I didn't have any 50, so I'd used a couple of hundreds. Yeah, so the last thing is to get some leads on. I need to attach a lead for the bias coming in. It's obviously going to the 5-volt regulator with a trim pot there, so I can adjust the bias. I think from the spec sheet, again, I think it's wanting to see about 250 milliamps, so it's going to a fair bit of juice. And this is for the serious power in, which is going to actually power the amp. So I mean, on the spec sheet again, I mean, it says up to 50 volts. Yeah, I probably won't get 50 volts, so I'll see what I can do. Yeah, very good. At the moment, I've just put a BNC on the end here. Probably I'll hardwire that to a bit of coax, because obviously it's going to have to go to a low pass filter before it goes anywhere. But yeah, quite pleased with that. And here we are. Here is the final amplifier. So now mounted, as you can see, on the heatsink with the bias cable on the left and the main power cable on the right, and of course the transistor soldered on. The only fly in the ointment was just down here. This obviously the board had moved a bit, so the hole didn't quite line up. So that one's bolted in, that one's not. But it's very securely bolted on, and the whole board's bolted, and I've got thermal paste underneath it as well, so I'm fairly confident that'll be okay. But I don't want to get too excited about any of this, because it's got to pass the smoke test first. But yeah, just from appearances alone, it looks a pretty fine looking amplifier. So let's hope it works as well as it looks.
And work it most certainly does, and very well. I'm not going to spend any time testing it or showing you any more of it this time, because I want you to see it in full effect next time as part of the completed rig, and we'll put it through its paces then, and you'll be able to see for yourself. But spoiler alert, I'm getting about 83 watts out. 83 watts, so I've never produced that kind of power before, and I am getting 50 volts to the power, thanks to my boost converter. So yeah, so 50 volts is powering it, and a little bit of bias, and 83 watts out. So that's brilliant. But much more about that next time. For now, thank you very much for watching, and yeah, tune in next time and see the finished thing. Thanks ever so much. 73. Bye bye.